Welcome to our video lesson on finding the least common multiple. Before starting today, I need you to turn to your learning goal sheet. We're working on learning goal number 8 down here. And you're going to fill in the blanks with find the LCM or least common multiple of two whole numbers. You're going to change the sign that was written there. Before it was a less than or equals to sign, which looks like this. That's what you have. But it should be this sign here, which is greater than or equal to, with the alligator sign pointing this way, with that, and then the 12. So you're going to find the least common multiple of two whole numbers greater than or equal to 12. If you know how to do this, or think of how well you know how to do this and give yourself your before level of understanding, please circle it over here. When you finish that, let's get started. We're going to work on pages 23 and 24 of your notebook today. Almost everything's going to fit on our guided note. There's one example you'll do on a separate piece of paper, and afterwards you're going to do your homework on page 24. All right, let's get started. Before we can talk about how to find the least common multiple, we need to talk about what it means. So a multiple is very different from a factor. It's actually the opposite of a factor. It is the product of that number and a non-zero whole number. For example, the multiples of 7 are 7, 14, 21, 28, 35, and 42. They continue on till infinity. A common multiple. A common multiple is a number that is a multiple of two or more numbers. So here I have our multiples of 7, and here are the multiples of 8. Let's see if we can find any that they have in common. It might be hard to find it, but if you go through the list, eventually you'll see that they both have 56 in common. So a common multiple between the numbers 7 and 8 is 56. Now, we're going to add the word least in front of it. The least common multiple is the smallest multiple that is common to all the numbers. So let's look at the multiples that are common between 4 and 6. They have 12 and they have 24. So in this situation, the least common multiple between 4 and 6 will be 12 because it's the smallest of the multiples that they share. Now, there's two methods we're going to go over for finding the least common multiple. When you're doing your homework or your practice or quiz or a test, you can do it whichever way you prefer. It doesn't matter to me. Just choose whichever way you like better or you find easier to do. Can you please write down the steps for the listing multiples method? The first one, list some multiples of both numbers. The second one, circle the common multiples. And the third, find the smallest one is the least common multiple of those two numbers. Let's use this method to find the least common multiple of 6 and 8. The first step is to list some multiples of both numbers. Remember, multiples starts with an M, so we're going to find numbers that are bigger or more than. Multiples start with an M, so that means it's more. So we'll start with 6. Then 6 times 2 is 12. 6 times 3 is 18. 6 times 4 is 24. 6 times 5 is 30. 6 times 6 is 36. 6 times 7 is 42. 6 times 8 is 48. 6 times 9 is 54. And 6 times 10 is 60. Now let's do 8. 8 times 1 is 8. 8 times 2 is 16. 8 times 3 is 24. 8 times 4 is 32. 8 times 5 is 40. 8 times 6 is 48. 8 times 7 is 56. 8 times 8 is 64. And I'm going to stop there. All right, so we've done number 1. We've listed some multiples of both numbers. Step number 2, circle the common multiples or the multiples that they share. All right, I'm going to go through and try to find any ones that they share. Here I've found 2. 24, they both have 24. Now let's keep going. They both also have 48. So we've circled the multiples they have in common. The last step, the smallest one is the least common multiple. All right, well, our smallest one is 24, which means that the LCM of 6 and 8 is 24. Now, this method is straightforward. However, sometimes it's easy to make mistakes, or it can be hard to figure out where to stop. That's where the next method can help us a lot. Method 2 is using factor trees, our handy-dandy friends which we've been using all week. The steps for finding factor trees. The steps for finding the least common multiple with factor trees. The first one, make a factor tree for each number. The second one, write the prime factorization. The third, circle each different factor where it appears the most. This step is the confusing step where some people sometimes make mistakes. Step number 4, multiply all the circled factors together. So steps 3 and 4 might seem a little bit confusing, but let's do it together. I'm going to do this actually on the next page so that I have a little bit more space. Alright, we are going to find the least common multiple of 6, 9, and 15 by using factor trees. Our first step is to make a factor tree for each number. Alright, let's start with 6. Two factors that we can multiply together to give 6 are 2 and 3. They are both prime. Because both 2 and 3 are prime numbers, we can circle them. And we know that our factor tree for 6 is finished. Now let's do 9. What factors, when you multiply them together, give us 9? 3 and 3, those are our only options. So now we have, 3 is a prime, and 3 is also a prime, so we finished our factor tree for 9. Now our factor tree for 15. What two factors, when you multiply them together, give you 15? We have 3 and 5. Now 3 is prime, so I'm going to circle it, and 5 is also prime, so I'll circle it as well. Now we've finished the factor trees for all of our numbers. Our next step is to write their prime factorizations. So 6 is equal to 2 times 3. I'm getting the numbers from up here where the prime numbers are that I've circled. 9. 9 is equal to 3 times 3. The last one, 15, is equal to 3 times 5. Alright, our next step. Circle each different factor where it appears most. This is the one that's kind of funny. What that's saying is we have to look at each factor and see where in what line it appears the most. Let's start with 2 because it's our first factor here. We're going to look through each of our prime factorizations and find where 2 appears the most. So 2 appears once in this prime factorization of 6, that's right here. 2 is here once. 2 doesn't appear in the prime factorization of 9, nor is it in the prime factorization of 15. So that means that 2 appears the most here in 6, so I'm going to circle it there. Alright, our next one is 3. In which of these does 3 appear the most? Well, 3 appears once in our first one, twice in our second one, so that's more than our first one, and once in our last one. So where 3 appears the most is here in our second one. Now, let's move on. We've already done 3. We've already done 3 and 3 and 3. So now we can do this 5. Where does 5 appear the most in our prime factorization? Well, 5 isn't in the 6th prime factorization or in the 9th prime factorization. So where 5 appears the most is down here. Now our last step is to multiply all the circled factors. So to find our LCM is equal to 2 times 3 times 3 times 5. How did I get that? I took the 2 from this 2 here. The 3 times 3 is here, and the 5 is right there. So I took all our circled numbers and I'm multiplying them together. All right, let's do that. 2 times 3 is 6. I still have my times 3 times 5. 6 times 3 is 18, and then I still have my times 5. And 18 times 5 I'll do right here. 5 times 8 is 40. 5 times 1 is 5, plus 4 is 9. So the least common multiple of 6, 9, and 15 is 90. That is a very large number, and it would have been really hard to get this number using method 1, listing multiples. It would have taken us a long time to get there, and we might have missed one. That's why I like this method so much. Let's do another example because it can be kind of confusing. One more example. So this time we're trying to find the least common multiple of 6, 9, and 10. Our first step is to make a factor tree for all three. The prime factorization, or two factors when I multiply together give me 6. That's 2 and 3. I am going to circle the 2 because it's prime, and the 3 because it's prime as well. All right, we are done because we've finished with prime numbers. Now let's do the 9. The two factors that multiply together to give us 9 are 3 and 3. Now they're both prime numbers, so I'm going to circle them both. Our next number, I'm actually going to move it over a little bit so I have more space, is our 10. What two numbers, when you multiply together, give you 10? Do 2 and 5. Our next step is to write the prime factorization for each number. So the prime factorization of 6 is 2 times 3. I'm getting that from the numbers up here, 2 and the 3. Of the 9 is the 3 times 3. And of 10 is 2 times 5. Our next step is to circle each different factor where it appears the most. Okay, this is where it might get confusing. Well, let's start with our 2. Where does the 2 appear the most? The only place 2 appears is right here, so I'm going to circle it because that's where it's the most. Okay, the next factor is a 3. Where does 3 appear the most? In this one, because there's 2 3s here. Now, we have another 2, but because it only appears here once and it appears here once, it means we can circle either of them. Our last factor is a 5, and it's only there once, so we circle it once. The last step is to multiply all the circled factors together to find the LCM. So our LCM is equal to 2, from right here, times our 3 times our 3, times the 5. All right, 2 times 3 is 6, times 3 times 5. 6 times 3 is 18, times 5. And 18 times 5 we just did, but we'll do it again. 5 times 8 is 40. 5 times 1 is 5, plus 4 is 9, so that gives us 90. This gives us the same LCM as we got with the previous one, but it's with different numbers. All right, hopefully you see how to find the LCM using factor trees. For your practice, you are going to use this QR code to do your IXL. You're working on the next page in your notebook. If you can't find it, if you don't have a QR code reader, go to our website. It's under Tuesday's work. Make sure you show your work for every single question. If you need more help, please look on our website. I've got some extra help on there that might help you. Also, feel free to rewatch any part of this video. All right, I'll talk to you later.